We will begin our course for the AS level mathematics, pure mathematics, by reviewing some of the basics of algebra. These things will not be directly asked in the examination, but you should know them because you'll have to use them in other contexts. So first of all, a variable is a letter or symbol that represents an unknown value. So for example, if you see an expression which says 12 plus x, the letter x there would be a variable. When variables are used with other numbers, parentheses or operations, they create what is called an algebraic expression. Okay? So for example, a plus 2 here is an algebraic expression. A, and you see parentheses, b, that is multiplication. A times b, that is an algebraic expression. 3m, 3 multiplied by m plus 6 multiplied by n minus 6, that is also an example of an algebraic expression. The coefficient is the number multiplied by the variable in an algebraic expression. So in the example, here is an algebraic expression, 6m plus 5. 6, which is the coefficient of the variable, is called the coefficients. Similarly, here is an algebraic expression, 8r plus 7m plus 4. 8 is the coefficient of the variable r, and 7 is the coefficient of the variable m. 14b minus 8, b is a variable, so the number multiplied to it is 14, therefore 14 is the coefficient of b. A term is the name given to a number, a variable, or a number and a variable combined by multiplication or division. Okay? So here is a few examples. The first example is a plus 2. That is an algebraic expression. A is a variable, that's one term, and 2 is just a constant number, that's another term. Okay? Here is another algebraic expression. 3m plus 6n minus 6. 3m is a term, 6n is a term, and minus 6 is a term. A constant is a number that cannot change its values. Okay? It's an algebraic expression. In an algebraic expression, the constant term is the one without any variable. So if there is no variable attached to the number, then it's a constant. Okay? So we've seen these examples in previous cases also, but here I have an algebraic expression 5x plus 7y minus 2. Okay? 5 is the coefficient of x, 7 is the coefficient of y, but here minus 2 is not multiplied to any variable, it's by itself. So that is the constant term of the algebraic expression. How do we write algebraic expression? We do not. There are certain conventions. For example, for multiplication, when you're starting to learn multiplication, you use the symbol for multiplication. But, it will take a lot of time and it will make things confusing if we write the multiplication symbol every time we're multiplying two numbers. Okay? So instead of writing 5 times n or n times 5, we just simply write 5n. So in an algebraic expression, when you see two numbers together, 5n, that means they are being multiplied. And the convention is that the number is written before the variable. The coefficient is written before the variable. Even though if I write it as n times 5, mathematically that will be correct, but the convention is that we write the number before the variable. Okay? Another convention is that when we multiply a letter by 1, we don't have to write 1. We don't write 1n, for example. Right? So 1n or n1 is written simply as n. So that's another convention. When we write expressions in algebra, again, division, you've seen this sign. This is the division sign. You're probably used to it from school. Yeah? But we don't use it anymore in algebraic expression because, again, it takes a lot of space and can get confusing in long algebraic expressions. So here n divided by 3 is simply written as n, and we write a little bar under it and then write 3 under it. That means the number on top is divided by the number on the bottom. Another important thing to remember is what is called the index notation. The index notation is that if I have a number multiplied to itself 2 times or 3 times or 4 times, then instead of keep writing it, it by itself, we use what is called an index notation. Here is an example. Okay? So here n is being multiplied to n. So instead of writing n, we simply write n and we put a number on top of it, 2, meaning n is being multiplied to self 2 times. And it says it's read n squared. So similarly, if I have n times n, I'm not going to write it n. No, I'm not going to write that. I'm going to write n, and I'm going to put little 3 on top of it. It's called n cubed, or n to the power 3. That's called index notation. Identities are important when 2 expressions are identical. Okay? Then we denote them by this 3-bar sign. It's called the identity sign. Okay? It's slightly different than the equal to sign. In the equal to sign, you've seen 2 bars. Here we write 3 bars. Okay? And I'll explain the difference in a moment. Okay? So for example, x plus x plus x is identical to 3 times x. Okay? They're identically exactly. They're basically 2 faces of the same coin. Okay? There is absolutely no difference except for how you see them. Okay? They're x plus x plus x is identically equal to 3x. Okay? This is an example of an identity. The important thing to note here is that in an identity, both sides are equal no matter what the value of the unknown is. Okay? So for example, if x is 4, for example, I have 4 plus 4 plus 4, that is identical to 3 times 4. Why? 3 times 4 is 12, and 4 plus 4 is also 12. So no matter what the value of x is, both sides will produce the same number. Okay? As opposed to what an equality is. Suppose I say x is equal to 2. Okay? In this case, x is equal to 2 is not identical to 2. Okay? It's equal to 2 because this expression is true only when x takes the value 2. If x takes the value 4, this expression is no longer valid. 4 is never equal to 2. So this is what an equality is, and this is what an identity is. In an identity, no matter what your values of x you assign, both sides will turn out to be exactly the same. Like terms. So if we have algebraic expressions, then of course they are made of terms. We've looked at that. Okay? And there are operators. We've looked at them also. Plus, minus, multiplication, division. And sometimes we use parentheses also, either to collect terms together or to multiply one term by another. We'll see examples of that as well. and we've seen that a term is made of numbers and variables, letter symbols. But a term doesn't include operators. You know that. We've seen examples of terms. Okay. So for example, 3a plus 4b minus a plus 5 is an expression. Okay. It has several terms in it. We have 3a is one term, 4b is another term, a is another term, and 5 is another term. Now, if you look at this, 3a and a are like terms, This is important, okay? Because they both contain a number and the letter symbol is the same, a. Okay? So if you want to understand like terms, if I say here, 3 apples, A stands for apples, A is an apple, and B stands for bananas. Okay. So I say 3 apples plus 4 bananas minus 1 apple plus 5 gives me what? Okay. So, of course, I can't add apples to bananas. That makes no sense. Okay. But I can add apples to apples, or I can subtract. From 3 apples, I can subtract an apple. Okay? So what is the result of these two? The result of 3a minus a is 2a. So I can simplify this expression and write it as 2a plus 4b plus 5. Okay? So what I've done, I've collected the like terms. Okay? You see examples of that also. Okay? So like terms are which have exactly the same variables in them. They are called like terms. Okay? So as I showed you in the previous example, when we get an algebraic expression, we like to simplify it. And one way to do that is to combine like terms together. Okay, important thing, just like we use arithmetic with numbers, exactly the same way we can do arithmetic with algebraic terms, like terms. 5 plus 5 plus 5 plus 5 is 4 times 5. That's arithmetic. In algebra, a plus a plus a plus a is 4 times a. Okay? So a takes it's just representing some number. So that is how we collect like terms. These are all like terms. Okay, so here is an example again in arithmetic. In the previous slide you saw examples of addition. Similarly here we'll see examples of multiplication. In arithmetic we have 7 times 4 plus 3 times 4 is equal to what? 10 times 4, okay? Because 7 times 4 is 28, 3 times 4 is 12, 28 plus 12 is 10 times 4 is 40. That's true. In algebra, it's pretty much the same thing. 7 times b plus 3 times b is going to be 10 times b. Same idea. Okay? So b is just taking the place of a number. Same thing. Okay? Or as I said, we don't write the multiplication sign. I'm going to simply write 7b plus 3b is equal to 10b. Okay? They're all like terms because they contain exactly the same variable. Alright, now we can mix and match. Okay, just like in arithmetic, we have plus, minus, multiplication all appearing in the same expression. Similarly, we can do the same thing with algebra. So in arithmetic here I have 2, number 2 plus 6 times 2 minus 3 times 2. What is that? That is 2 plus 12 minus 6. What is that? 2 plus 12? 14 minus 6 is 4 times 2, 8. Okay? We know that's true in arithmetic. Okay? Exactly the same thing you will see will be true in algebra. Here 2 will represent the number 2. X, which is 2, for example, plus 6 times x, like this one, minus 3 times x is 4x. Okay? Again, this is an example of collecting like terms. Okay? X plus 6x minus 3x is equal to 4x. They're like terms because they all contain the exact same variable. Okay, when we add or subtract like terms in an expression, we say we are simplifying an expression. That's what it means to simplify an expression. So a lot of times you'll see in your problems, in your questions, that okay, find the answer to such and such problem and simplify the expression. Okay? Well, what happens a lot of times if you do not simplify the expression, you will lose points. Okay? What they mean by simplifying the expression is basically collecting the like terms together. That is the basic idea. And you also need to remember that an expression can contain different like terms. It doesn't have to have just a like term. It doesn't have just A. It could have B, C, X, Y. Okay? So you have to collect all the B's together, all the C's together, all the X's together, and so on. Okay? Here is an example. We have 3a plus 2b plus 4a plus 6b. Okay? Here, 3a and 4a are like terms, and 2b and 6b are like terms, okay? Because they're exactly the same. Okay? So I write 4a with 3a, and I move 2b up here with 6b. Okay? Now I'm going to collect these two, 3a plus 4a, and collect these two together. Okay? So 3a plus 4a is 7a, and 2b plus 6b is 8b. That's it, I'm done. I cannot now combine these two because these two, 7a and 8b, are not like